Hello friends, today we will discuss the Beckmann rearrangement. The Beckmann rearrangement is named after the German chemist Ernst Otto Beckmann. Now, what is Beckmann rearrangement? It is just a conversion of ketoenzymes into unsubstituted amides in the presence of catalyst. Now, what is catalyst? Catalyst is a substance which speeds up the rate of reaction without itself consumed. The catalyst can be protic acid like sulfuric acid, phosphoric acid, HCl. It can be Lewis acid like thionyl chloride, PCl5, or acid anhydride or acyl halide. The Beckmann rearrangement is an acid catalyzed conversion. That is, the reaction is catalyzed in the presence of acid or H positive. Here is the reaction. This is the ketoenzyme. How is it formed? It is formed on reaction of ketone and hydroxylamine via condensation reaction. Condensation reaction, that is the loss of water molecule, which results in the formation of ketoenzyme. NOH, C double bond NOH, we get ketoenzyme. Ketoenzyme in the presence of acid or catalyst results in the formation of unsubstituted amides. This is unsubstituted amide. Amide CONH2 is amide. Okay. The mechanism for the Beckmann rearrangement. The first step of the Beckmann rearrangement is protonation. The proton adds to the highly electronegative atom oxygen. Why the protonation occurred at this step? Because as the proton adds to the oxygen atom, it results in the formation of a better leaving group, that is water molecule. Okay, the protonation is carried out in the presence of acid, that is protic acid, which is catalyst, which acts as catalyst. Okay. Now the second step is migration. That is, one of the substituent attached to the carbon atom migrates to the nitrogen atom. It is the slowest step and it results in the formation of N-alkyl nitrilium cation. This N-alkyl nitrilium cation is resonance stabilized. Here we get this lone pair of electron moves like this and result in formation C triple bond N is positive as it is trivalent, having four bonds, so it is having a positive charge. The third step of Beckmann rearrangement is the nucleophilic attack by water molecule. Water, the lone pair of oxygen atom, attacks on the electropositive carbon atom, and there will be a transfer of electron to the nitrogen atom, which results in the formation of this species. And now the oxygen having a positive charge, which is unstable. So there will be a transfer of electrons to oxygen atom. There will be loss of proton. Okay, which results in the formation of enol form, R dash C double bond N bond R here, or OH. So which this enol form can tautomerize to keto form via keto-enol tautomerization, and we get unsubstituted amide. As I already told, the role of catalyst is just to convert hydroxyl group into a better leaving group. We have just seen in the mechanism that the protic acid like sulfuric acid, hydrochloric acid or phosphoric acid catalyze by simply protonating the enzyme, while others like PCl5, thionyl chloride, these esterify the oxime. Now we are taking the example of Beckmann rearrangement using catalyst arene sulfonyl chloride. So here is the reaction. The ketoenzyme, when reacts with arene sulfonyl chloride, gives sulfonate via loss of HCl. So there will be a removal of HCl molecule and we get sulfonate. The second step is, this is the first step, and now the second step is migration. One thing you have to know, that out of these two substituents, which group will migrate? So the group which is anti to the OH group or this group will migrate. to this nitrogen atom. So this R substituent will migrate to nitrogen atom, and what we get? We get an alkyl nitrilium cation. Okay, the third step is the nucleophilic attack via any nucleophile. Here is aryl sulfonate, and we get this suspicious R C bond OSO2R double bond NR. So now it reacts with water molecule to form an enol, which tautomerizes, that is it undergo ketoenol tautomerization to form an substituted amide, which is our product. Okay. Ketoxines generally show two geometrical isomers, syn and anti form. Syn means same side and anti means opposite side. So now this is a ketoxine. So this R dash is sent to this lone pair that is on same side, and anti to this hydroxy group that is on opposite side. Similarly, R dash is sent to this hydroxy group and anti to this lone pair. Okay. In Beckmann rearrangement, the group anti to the hydroxy group will migrate. We are taking an example. This is an ketoxine. When it reacts with PCl5 or any protic acid like sulfuric acid, HCl, phosphoric acid, results in the formation of an substituted amide, and it is the sole product of Beckmann rearrangement. That is, it is the only product. Now out of these two groups, which group will migrate? This phenyl group, because it is anti to this OH group. Okay, so the group which is anti to the OH group or hydroxy group will migrate and result in the formation of an substituted amide. Now the ketoxine structure was established by via base induced cyclization. That is, when the ketoxine reacts with base, then results in the formation of cyclized product. Now we will see the effect of substituent. If the electron withdrawing substituents, that is minus R group, attached to the migrating aryl group, that is the group which is migrating, if it has electron withdrawing substituent attached to it, then it will retard the rate of reaction. But if electron donating substituents attached to it, then it will accelerate the rate of reaction. That is, it means speed up the rate of reaction. Okay, so now the question is how it will accelerate, because the migrating group is better able to render anchimeric resistance to the removal of leaving group via transition state. What does it mean? It means the migrating group promotes anchimeric resistance. That is, it shows neighbor group participation, which helps in elimination of leaving group. How? Via transition state. Okay, so the stereochemistry shows that it is a concerted mechanism. It's a concerted reaction. Okay, and one thing you have to see is the stereochemistry in Beckmann rearrangement is not general. Sometimes what happens, a group which is sent to the that is on same side of hydroxyl group is found to be migrated. Actually, what we have seen, we have said that the group which is anti to the hydroxyl group will be migrated to nitrogen atom. But here, the group sent to the hydroxyl group is found to be migrated. You can say just an exception. Sometimes it happens. One thing to be noted is an important mixture of amides may be formed, particularly if both groups present on carbon are alkyl groups and catalyst is proton acid or protic acid. Okay, so you can, if we have both the group, that is the substituent attached on carbon atom, are alkyl group, and the catalyst we are using is protic acid like phosphoric acid, sulfuric acid, then mixture of amides can be formed. For example, okay, when we react a mixture of oximes with sulfuric acid, that is a protic acid, then it results in the formation of 4 products. This product is formed when this group migrates to this nitrogen atom. Why this group migrates, not this one? Because this group is anti to this hydroxy group. okay, and result in the formation of product A. When this species migrates to this nitrogen atom, this results in the formation of product B. Now the C and D. How these two products are formed? When this group migrates to the nitrogen atom of another molecule, okay, and vice versa, means this species migrates to the nitrogen atom of another molecule, then we get C and D. Okay, so these A and B, these two products are normal products, which are we expected. Okay, these two are new products, which are called cross products. Got it? Now, one thing is important. In the presence of proton acid, like sulfuric acid or any acid, syn and anti form are readily converted. It's convertible. We can convert it with the help of proton acid. See, here it is anti with respect to R dash. Okay, when we add we add acid, any acid like sulfuric acid, then a hydrogen adds to this nitrogen atom, and this will result in the formation of a carbocation. The carbocation is planar species, so it can arrange itself OH on above side and hydrogen below. So when deprotonation occur, we get R dash, which is syn to this syn to hydroxy group. Okay, here R dash is anti to the hydroxy group, here R dash is syn to the hydroxy group, and anti with respect to R. Okay. Mechanism given in scheme 1 is supported by following facts. So which mechanism? This one. We have done it now. This mechanism. So the first fact is this. First fact is the rate determining step involves the formation of nitrogen cation, and the rearrangement should proceed faster in polar solvent, which facilitate ionization. So this is the slowest step, and it is the rate determining step. Okay, so if this reaction is done in polar solvent, then the reaction is faster. Okay, why? Because it promotes ionization, it facilitates ionization, so the reaction should be done in polar solvent. Okay, the second fact is that if you have taken the substrate in which the migratory group is chiral, the substituent, the migratory substituent which is migrating to the nitrogen atom, if it is chiral. What is chiral? That is the carbon atom having 4 different substituents attached to it, and it is optically active. Okay, so if the migrating group is chiral, then what will happen to the stereochemistry in product? So there will be a retention in configuration in the chiral carbon. Retention of configuration will be there. Okay, so you can see here the ethyl group below the plane, and in the product what we get is below the plane. So according to Young, rearrangement of an optically active form, that is chiral oxime, to the amide, so the ketoxime, and here we get a product and substituted amide. Occurs with about 99% retention of configuration in chiral carbon. Okay, and the third fact is that is the oxygen atom of the oxime. Oxime is what? This is the ketoxime. This oxygen atom is eliminated during the rearrangement. During rearrangement, the first step is removal of oxygen as water molecule. Okay, so oxygen atom of the oxime is eliminated during the rearrangement. So in the product the oxygen which we get is via intermolecular process. How can we prove it? When unlabeled benzophenone oxime is treated with sulfuric acid which acts as catalyst, and water molecule and labeled water molecule which acts as nucleophile. Okay, then in product we get the same percentage of labeled oxygen, which labeled oxygen in the product. So which shows that the oxygen atom of oxime is eliminated during the rearrangement and the oxygen transfer occur through the intermolecular process. Okay, that is oxygen comes from some another molecule, that is from nucleophile. Okay. Now next is second order Beckmann reaction. There are certain substrates, that is certain ketoxines, in which one of the substituents attached on carbon atom is either tertiary group or it possess heteroatom, okay, at beta position. Okay, so in that case and fragmentation process occur instead of rearrangement, that is fragmentation dominates over rearrangement. Okay, the second order Beckmann rearrangement is the result of, is a consequence of enhanced stability of carbocation, that is due to the enhanced stability of carbocation the second order Beckmann rearrangement occur. Okay, so for example this one here, the carbon C double bond NOH at beta position carbon having the substituent which is tertiary group. So there will be fragmentation process, that is second order Beckmann rearrangement occur. So this bond cleavage occur here, this bond cleavage result in the formation of this product and a nitrile as a product. We get a nitrile. Okay. Here in this C double bond NOH, here alpha beta position, here is a beta position, at beta position there is a heteroatom. So fragmentation process occurs, results in the formation of this product. Similarly, C double bond NOH oxime at this carbon, the two substituents attached, then this is a heteroatom which is present. So as in the presence of acid result in the formation of this product, nitrile. How it happens? The reaction proceeds as follows. Like the bond, the two electrons of this bond move to this and results in the formation of nitrile as product. And there will be removal of the leaving group will eliminate. Okay. Now, if the substituent attached to the carbon atom in ketoxime contain hydroxyl group, okay, then there will be then what had happened, isonitrile will be the product. Okay, so the ketoxime on reaction with arene sulfonyl chloride in the presence of pyridine gives this sulfonate. The phenyl group now, because it is anti to this hydroderivative sulfonate, so phenyl group migrate to this nitrogen atom and result in the formation of this product. Now there will be a shifting of bond occurs and result in the formation of isonitrile as product. Okay, and benzaldehyde. Let's summarize it. Firstly, we have done what is Beckmann. Firstly, we have done what is Beckmann rearrangement. What's Beckmann rearrangement? It's a reaction of ketoxines in which ketoxine reacts with sulfuric acid, PCl5, SOCl2, etc. These type of catalysts to give unsubstituted amides. Then the mechanism using protic acid like sulfuric acid, hydrochloric acid and aprotic acid like arene sulfonyl chloride as catalyst. Then the effect of substituents, that is electron withdrawing group stop the reaction, that is retards the reaction, while electron donating group will accelerate the rate of reaction. Then the mixture of amides are formed when the substituents are alkyl group and the catalyst we used is protic acid. Okay. Then the second, we have done the second order Beckmann reaction. What is second order Beckmann reaction? In which when the substituents on ketoxime are tertiary alkyl group or it possesses heteroatom at beta position, then fragmentation dominates over rearrangement and we get RCN as product. So that's it. Thanks. Stay safe. Stay happy.